Okay, my dear students, so let us do this problem with the help of Geogebra. Okay, so the lengths of pregnancies in a small rural village are normally distributed with mean 269. So mu is equal to 269. And standard deviation that is given, and the standard deviation is sigma. Sigma is equal to 16 days. So it is 16. Okay, that's given. Now, in what range would you expect to find the middle 50% of most of the pregnancies? Okay, so it follows the standard normal distribution. So let us draw a standard normal distribution curve there. This is the main value, that is mu. And now we are going to plot the middle 50%. Okay, so say suppose this is the middle 50%. So all together will give you the 50%. So it is 0.50, the area, right? This is the 50%. Okay. Okay. That is the middle 50%. And we want to find this value. So suppose it is A and this is B. We want to find the A value and B value, and that will be the answer. So if we find out A there, that will be that value, and this is the B value. Okay. Now, how do you find this value? So, let us think in another way. This is 50%. So, can you say what will be this area? So, this area is half of that 50%, because that middle 50%, that is half portion will be on the left side, half portion will be on the right side. Okay. So, this portion, the area under this, the shaded area, is the half of that, that is 0.25, right? And if it is 0.25, can you say, what about this one? And that's again what? That's again, we know, that's again, let us color that with another ink. So this is the initial half of that one. So total area under the curve is 1. So this is the blue portion is the upper 25%, and this is the one more 25%, right? So all together 25 plus 25, that together give you the left half, and if you take the other one, that will be the upper 25, right? Okay. So actually that is divided into again one more 25. This is the last 25. Okay. So we want to find A and B. How will you find A and B? So if we take this yellow region, what is that? Probability of that value X less than or equal to A, and what is that? That is the yellow area, this one. So it will be 0.25. And we need to find A. For that we can take Geogebra, and we want to input 269 as the mean, then 16 as the standard deviation there. Okay, so I want to change that is 16. 16. Okay, so it is going to be 16. Okay. Then this area, that is 0.25. Okay, so it is 279.79. So A is equal to 279. What about that one? Take that again. Oh, it's not the upper one. It is the less than or equal. So we want to pick the first one, 279.79. Oh, it's 0.25. Okay, it's 258 actually. It's my fault. 258.208, but we are asked to find to one decimal place, so we can write it as 258.2. Okay. Now, if we want to find B, then we can move on to the upper, right? So it is probability of x greater than or equal to the last 55%. I mean b is equal to 0.25. That means this area, right? This is the area. X greater than that, b is 0.25. Again, we can input that in GeoGebra. Pick the last one. So it will be, yeah, it's 0.25. 0.25. Yeah, that is 279.79. So it is 279.8. We can round it out. So probability of x greater than or equal to b means b is equal to 279.79. So we can round it as 279.8. Okay. So that's why the first value is that much. Okay. So that is the one range. So a value is 279. I mean 258.2 and b value is 279.8. Got it? Okay. Now we are moving to the second one, and the second one, this one, and that is from a population. No, not from a population, it's from a sample. And the sample of size 41 is given there. So everything remains the same, but we are dealing with a sample. So the sample of size n is equal to 41. By central limit theorem, we know if you draw a sample, the mean value of the sample will remain the same. So mean of the sample will be the mean of the population, and that is equal to 269. Whereas the standard deviation of the sample, that will be given by sigma over square root of n. That is 16 over square root of 41. And again, we need to find the same percentage. So the only change is a and b. So we can replace this with small a and with small b, but the values will be the same. But the mu and sigma, mu will be the same, sigma will change. Okay, let us take the GeoGebra. Mu will be the same. 16, it will be 16 over SQRT parenthesis 41 close the parenthesis end up. Okay, and that will be the value, and then we want to find the same thing, probability of the small version. So the probability of x less than or equal to small a will be 0.25. Apply that in GeoGebra. So it's again 0.25. No, with first one. Pick the first one. It's 0.25. Yes, 0.25. 0.25. It will be 267.3. So a value is 267.3. And the same way we can find probability of x greater than or equal to b, the upper portion, this portion, that is again 0.25. So input that in GeoGebra. It's pick the last one, and the value is 0.25. And it will be 270.68. We can round it as 270.7. So b is equal to 270.7. Okay. So the only thing is that first one is from the population. So that's why mu and sigma will be the population mean and population standard deviation. But the second one is from a sample. So the mean will be the same, 269. But the standard deviation will change in the form of sigma over root n. But everything remains the same. The area under the graph will be the same. So we can find a and b. That's it. I think that makes sense. Okay.